Hi everyone. Since you are familiar with the concept of a tangent to a curve, in this section, we will learn a method for determining the slope of a tangent at a given point on a curve.
When we look at a line, we can easily know that the slope m of the line joining points P1 and P2 is this. But what can we do if we only have one point? Let us take a look at this picture. Consider a curve and a point P that lies on the curve. Now consider another point, Q, on the curve. The line joining P and Q is called a secant. When point Q moving towards P along the curve, the secant of PQ gradually becomes the better estimate of the slope of tangent. This suggests the following definition. The slope of the tangent to a curve at a point is the limiting slope of the secant PQ as the point Q slides along the curve toward P. In other words, the slope of the tangent is said to be the limit of the slope of the secant as Q approaches P along the curve. Now let us see one example. To solve this question, we need 2 points, P and Q. So the slope of the secant PQ is. And finally, we get the answer, 4 plus h. When h approaches 0, the value of 4 plus h approaches 4, so the slope of the tangent at point 24 is 4. Now we can derive a formula for the slope of the tangent to the graph of any function. Point P is a fixed point, while point Q represent any other point on the graph. So we conclude that the slope of secant is, and the slope of tangent as a limit is.
This formula, also known as the first principle of derivative, which we will discuss later.
Now we will look at the rate of change. The average velocity of an object is change in position over change in time. Also can be written as this. For this picture, we can conclude that the average velocity over this time interval is this, which is the same as the slope of the secant PQ. The velocity at a particular time is calculated by finding the limiting value of the average velocity as h approaches 0. To summarize, the average rate of change is this, when x changes from e to e plus h. And the instantaneous rates of change is just take the limit based on the average rate, like this. Remember, this formula is also the slope of the tangent to the graph when x equals to e. After we have a general understanding of slope of tangent and rate of change, now the derivative is coming. In the previous learning, we already encountered limits of the form, which has 2 meanings. The slope of the tangent to the graph and the instantaneous rate of change of fx. Since this limit plays a central role in calculus, it is given a name and a concise notation. It is called the derivative of fx at x equals e. Written as this, to determine the derivative at a number is just this formula. Now let us see one example, where x equals to 1, y equals to 2, so the point is 1, 2. To solve this question, we need this formula, then substitute, simplify. Remember, the question requires the equation, not just the slope. Then we reach the final answer, y equals to negative 2x plus 4. Here is the graph of example 2. The blue line is the slope of tangent. What about the red line, which is perpendicular to the blue one? So this line, we call it the normal line. Whenever we talk about perpendicular, it means the product of the 2 values is negative 1. Therefore, for this question, the slope of the normal line is just the negative reciprocal of negative 2, which is 1 over 2. Now let us do a brief summary. In this section, we learn how to determine the slope of the tangent to a graph. Then we learned average and instantaneous rates of change and relate these to slope of tangents. Also, we learned simple rational function using first derivative and the normal line. That is what we learn in Unit 1. That's all for today's class. Bye.